All right, thank you so much for joining us today. In this video, we are going to talk about integration by substitution, which we call it the U-substitution. So everything that you've done is just kind of straightforward. So now we are going to talk about U-substitution in the context of definite and indefinite integrals. So let's start. So now here we are using U-substitution to solve this. The idea is that we cannot just solve this one straight, so we need to do some substitution here, right? So what I'm going to do is, since this one is just one function, here we are going to let, so using U-substitution, we are going to let U to be equal to 5x plus 7. Remember, this one can be written as 5x plus 7 to the power 1 over 2 the x. So we let U to be equal to the function inside the what? The parentheses. Then what we are going to do is, with U substitution, we try to change all the variables from x to u, right? If you cannot change all the variables from x to u, then you cannot use the U substitution to solve. So that's basically what we are doing here. So now let's differentiate. Du over dx is equal to 5. The reason is that now if we replace this one by u, then we have dx here, so we need to change the ds to what? Du. So it means that this implies that du is equal to 5 dx, and this implies that dx is equal to du over 5. So you see that this implies that the integration square root of 5x plus 7 dx now will be equal to integration. We know that what is inside the parenthesis here is u, so we are going to have u to the power 1 over 2 times, we know that the x now is equal to du over 5. So this is du over 5. And we see that now the function here has changed from x to what? U, all of them. As soon as we have, let's assume that we have divided by x, then we cannot use integration by substitution. We need to use other technique. But since we are talking about U substitution, all the U substitution here is going to work. So this is going to be 1 divided by 5 out, u to the power 1 over 2 du. Then we use a technique that we learned from the previous videos. So this is, we need to use the power rule here. So this is going to give us 1 divided by 5. And when I integrate this, I'm going to have u 1 over 2 plus 1 divided by 1 over 2 plus 1 plus my constant, because this is indefinite. So this is going to be 1 over 5 times 3 on 2 divided by 3 on 2 plus this. I can write this one as 1 over 5 times 2 on 3 u to the power 3 on 2 plus c. But we know that u is equal to 5x plus 7. So that's the reason why we call it U substitution. So we need to substitute it back. So this is going to give us 2 divided by 15. Now u is equal to this. So I'm going to have 5x plus 7 to the power 3 on 2 plus c. So this is what I'm going to get for the integration of this. So this is what we call U substitution or integration by substitution. So this is kind of like the change rule, right? And the derivative. Good. This is kind of the change rule and the derivative. Now let's look at this one too. This one too, we are going to use the same U substitution because this one is under this. So here, the question is, now, what should be my U? Because we have two functions here. Anytime you are dealing with U substitution, you need to pick the function with the highest degree. So we have one function here, not this one. Look at the function here. The function here, and we have another function here. Which one is having the highest degree? We can see that this is the one which is having the highest degree. So that is what is going to be our what? U. So x cubed minus 3x plus 1. And with U substitution, the idea is that whenever you have two functions, then if you pick the one with the highest degree and you differentiate, you get the one with the least degree. That is basically what we are going to do here. So you will see that anytime we differentiate this one here, we are going to have what is here on the top so that we can cancel it out. If we are not getting that, then we cannot solve it. So now let's differentiate this, and we see that we are going to have 3x squared minus 3, right? and here we can factor 3 out, and we see that we are going to have what is here. So this implies that du is equal to 3 out x squared minus 1 dx, right? And then we can say that this implies that du over 3, I'm dividing through by 3, is x squared minus 1 dx. So now we can now start by using the u substitution. So x squared minus 1 divided by x to the power 3 minus x plus 1 all to the power 6 dx. And one thing that you need to notice here is that whenever you are choosing your u, you don't choose the power in addition like this to the power 6. No, you just pick the function under the square. So now this is going to give us, now remember something here, I can combine this and that, and then when I multiply this and that, I'm going to have this here, right? And this one's supposed to be this. Or one way of doing this is I can make the s the subject here. When I'm making the s as subject here alone, I can write this one as the x, and this one will be 3x squared minus 1. So let me rewrite this one again by making, so du will be 3x squared minus 1, which is the same as the x. So I divide through by this, and then I have that. So now when I'm doing it, I don't know this one, so this one is here, divided by, I know that this here is equal to u, so I'm going to have u to the power 6 times dx is equal to the whole of this. So this is going to give me this divided by 3x squared minus 1. And anytime you do this and you do it right, you should be able to cancel out so that all the xm will just go away. And then now we have u1 to the power this du. Now since this one is not 1, we cannot say that this is ln. So we can write this one as u to the power minus 6 so that we can use the power rule to solve. So this one will be u, so add plus 1 to it, getting minus 5, then you divide by minus 5 plus the c. Then what is u? So we know that u is equal to this. You plug it in and then you are done. So this is going to be minus 1 over 5. Then u is x to the power 3 minus 3x plus 1 to the power minus 5 plus c. So this will be the integration for this. So this is the u substitution. Let's take more example. Now this one, we have the shortcut, but you can also use the u substitution. So I'll show you all the two. The one that you think it's good for you, then use it. So I'll go through the long process. When I'm done, then I'll show you the shortcut. So let's go through the long process. So the long process here is let u to be equal to the function inside the trig functions. So anytime you are doing u substitution for trig function, your u should be what's inside the trig function. So this is going to be 4x. Then we find du over dx to be equal to 4. This implies that du is the same as 4 dx, and this implies that du over 4 is equal to dx. Good. So now that we've gotten this one, then we can now do substitution. So let's do that. This integration now is equal to cos. Now 4x is the same as u, so I'm going to have u times, oh, I should have added this one. All of them should be going with dx. Okay, good. So now what is dx? Dx is du over the 4. So du over 4. So this is going to give us 1 over 4 cos u du, right? So now we've changed everything to u, so we can now integrate. So 1 over 4, when I integrate cos, I get sine. So this one is going to give me sine u plus c. Then when I finish, I need to do backward substitution. U is equal to 4x. So this is going to give me 1 over 4. 1 over 4. U is 4x. So I have this. So this is the integration. Now, let me show you the shortcut. The shortcut here works, yes, when this is to the power 1, right? The degree is 1. So this is going to give us, if I want to integrate this, I use a shortcut. The shortcut is this. I differentiate the cos. I know that when I differentiate cos, I'm going to get sine. So this is going to give us sine 4x. Then I will divide it by the derivative of what is inside the bracket. So when I differentiate 4x, what am I going to get? 4 plus c. And this is what is here. So these are some of the shortcuts that you can use to solve objective questions, right? So instead of going through all this, but if it is subjective and they are saying that use a U-Substitution, then you need to go through the process that I went. But if it is objectives, then this is the shortcut that you can use to differentiate or integrate this function here. Straightforward. Good. Now let's talk about, okay, let me just maintain this one here. So let me move it up small so you know the shortcut now. Okay, let me click this. Now let's talk about the next question here. So now this one here is the same as integration sec 2x plus 1 all squared dx. So that's what you need to know. So this is the question here. Good. This is the function here. So we need to use substitution, right, to solve this. So that's basically what we just need to do. So let's do that. I'll let u to be equal to what's inside the parentheses here. So u is equal to 2x plus 1, right? Then what is du over dx, which is 2. This implies that du is equal to 2 dx and du over 2 is equal to this. So now let's do substitution from there. Now this is going to give us integration sec. So let me put the square back. Let me put the square back to where it was. So I'm going to have sec squared, and then everything in the parentheses here is now equal to u. So I'm going to have the u times dx is equal to du over 2. So I'm going to have du over 2. So guess what I'm going to get from here? This is going to give us 1 over 2 sec squared u dx. And the question is, what function, when I differentiate, I get sec squared? That's the tangent, right? So this is going to give us 1 over 2 tangent of u plus my constant. But u is equal to 2x plus 1. So this is going to give us 1 over 2 tangent of 2x plus 1 plus my constant, which is c. Plus my constant, which is c. Good. So this is what we are going to get from here. Good. Now somebody is asking a question: can we use shortcut for doing this? Can we use shortcut for doing this? Yes, of course you can use shortcut for doing this. But here you need to really pay attention to what I'm coming to do here, right? So let's go through the shortcut here. Now the shortcut here is going to give us something like this. So first, I know that when I differentiate sec squared, I'm going to get tan, right? So I'm going to have it to be tan 2x plus 1. Then I divide it by the derivative of, the derivative of what's inside the parenthesis, which is 2. So you see that this one is the same as this. So if you know how to differentiate the trig functions, they are pretty much straightforward when you want to use a shortcut. So integrate the sec function. You know that when you integrate sec squared, you get tan. Without touching what is inside the parenthesis, then you divide it by the derivative of what is inside the parenthesis, and then you are there. Good. Somebody saying that I love the shortcut. Yes, it's good to love shortcut. Good. Let's go through this one too. So the same thing with this one too. Let u to be equal to, so the same idea. Let u equals. So I hope you've used a shortcut to get the answer already. So let u to be equal to this, right? And then du over dx will be equal to 1. So du will be the same as dx, right? So let me shift this one here. So now that we have this one, then what is this? This will be equal to sine u times du, because we know that x plus 4 is u and dx is du. So integrating this, we know that when I integrate sine, I get minus cos u, then I add plus c. I know that u is this, so I'm going to have this one to be equal to minus cos 4 x plus 4 plus c. So this is my solution. Now let's use the shortcut. So the shortcut is very simple. So I'm putting the shortcut here. Shortcut, when I differentiate sine, I get minus cos. So x plus 4. And then when I differentiate what is inside the parentheses, I'm going to get it to be divided by 1 plus c. And this is the same as that. So this is the shortcut that you can also use to solve your function. Okay. Now let's do the last one here. The last one here, this is good. Now let's see how we can solve this. Good. So here we are going to use substitution, right? We are going to use substitution, but let's see how we can do the substitution here. This one, we have two functions, cos 5x cubed and then sine 5x dx. Remember, this one can be written as cos 5x all to the power 3 sine 5x dx. Now, when we have two trig functions combined, you cannot do what we were doing right now. You cannot do like let u to be equal to what is inside the function, right? Or what is inside the parentheses. We don't do that. Now, because we have two functions combined, what we just want to do is look at the degree of the functions. Because I know that when I differentiate sine, I'll get cos. And when I differentiate cos too, I'll get something like sine, right? So I can let u to be equal to either cos or sine. But here, for me to let u, I need to look at the one with the highest degree, right? So the one with the highest degree here is cos, because the cos is to the power 3 and this is to the power 1. So here I will let u to be equal to cos 5x, right? The idea is that if I don't do that, I cannot cancel this, because if I let u to be equal to sine, the cos is to the power 3, and now when I differentiate, I'll have just one cos and cannot cancel all the 3 cos. So since this one is just 1, and when I differentiate this, I'll get 1 sine and it's going to cancel it out. So that's basically what we are doing here. So now let's find the derivative. Du over dx is equal to, when I differentiate cos, I get minus sine. So minus sine 5x. Then I differentiate what is inside the parentheses. Let me put this one inside parentheses. So times 5. So this is what I'm going to get. So I have du to be equal to minus 5 times sine 5x dx, right? And then I can make dx the subject. So I'm going to have du over minus 5 sine 5x is equal to dx. Then I do substitution. So let's do the substitution. Let me just move this to this side. So let's do the substitution. I'm going to have integration. This is equal to u. So I'm going to have u to the power 3 times sine 5x. Dx is du over minus 5 times sine 5x. And then the magic will happen. But if I use the cos, you will see that the cos will be to the power 3 and here will be cos. And I can cancel one of the cos and it will be to the power 2, which I cannot get away with the x. So pay attention to this one too. So this is going to give us, I can factor 1 over minus 5 out. So I'm going to have minus 1 over 5 out. And this will be u to the power 3 du. And this is going to give us minus 1 over 5. And this is going to give us u to the power 4 divided by 4 using the power rule plus c. So this is going to give us, u is this. So I'm going to have minus 1 over 9 cos 4 5x plus c. So that's what I'm going to get. from here. Or if you don't want to put the 4 here, this to the power 4. And this is what you are going to get as your final results. Somebody is asking, can we use shortcuts for this? No, we cannot use the shortcut for this one because we have two trig functions together, right? This kind of product rule. So you cannot do the idea of differentiating and doing this. Unless this one, you are very, very good with the shortcut, then you can just go through the process by knowing that since this is having the highest degree this, then I'm just going to differentiate this and then multiply it by this, but it's not a proper way of doing it, so I'm not going to show you. Good. Let's look at D. We want to integrate this. So what should be my U? So the U should be the one here, right? It should be the one here. So I'm going to have U to be equal to square root of this. So I know that this is the same as x to the power 2, 1 over 2. So the U over the x is going to be 1 over 2 x to the power minus 1 over 2. Let's try and simplify this. The U over the x will be equal to 1 over 2. This is the same as times 1 over x to the power 1 over 2. And this is the same as 1 over 2 times 1 over square root of this. And the U over the x is equal to 1 over 2 root x. So it means that this implies that du is equal to 1 over 2 root x dx, and dx will be equal to 2 root x du. Good. So now that we've gotten this, I can just clean this, the whole of this. So we have u and we have dx. So now we can now do the integration. So this is equal to, now this is u, so I'm going to have e to the power u divided by, I'm not going to replace this one by u, but if we do that, it's the same thing that's going to happen. So if I want to do that, if I want to replace this by u, I can do that. So this one going to be divided by u times, now dx is equal to this, and I'm going to have 2 square root of x du. But mind you, remember, square root of this one is also u, so you need to do the substitution again with u here. But if you maintain square root of x, then square root of x will cancel square root of x, so any of them works. So this is going to be this divided by u times 2u du, and u will cancel the u. So I'm going to have 2 integration u du, and when we integrate this with respect to u, we are going to have the same thing again, c, and u is equal to this. So this is going to give us 2e to the power square root of x plus c. Integration by substitution, U-substitution. Now let's look at this one too. Now if I have a function that involves len and x, the question of which one should be my u, right? So here we are going to choose u to be the len of x. So here we let u to be equal to the len of x. The idea is that when I differentiate len x, I'm going to have 1 over x. And this implies that du is the same as 1 over x dx. And this implies that dx is equal to x du. So this will help me to write this one as u divided by x times dx is this. So I'm going to have x du, and then the magic happens, and I'm going to have integration u, and this is to the power 1, so this is going to give me u squared divided by 2 plus c, and u is equal to the len function. So finally I'm going to have len of x all squared, len of x all squared plus c divided by 2. So that's what I'm going to get for E. Let's take F. I think we are almost done. Let's take this one. Good. Now this function here is also, as I said, anytime you have two functions, look for the one which is having the highest degree. So you see that this is 2 and this here is 3. So the function is this and that. So we need to let u to be equal to the function with the highest degree. And the idea is that anytime I pick the one with the highest degree, when I differentiate it, I get the one with the least degree or the lowest degree. So du over dx is going to give us, this is going to give us 6x squared, right? And this implies that du is equal to 6x squared dx, and this implies that dx is equal to du over 6x squared. So now let's plug them in. This will be, everything here is u, so I'm going to have u to the power 7 times x squared times dx is du over 6x squared. X squared will cancel the x squared, so this one will be left with 1 over 6 integration u to the power 7 du, and then 1 over 6 u to the power 8 divided by 8 plus my constant, and I know that u is equal to this. So plug it inside and then you are done. So you see that U-substitution is very simple. So 6 times 8 or 8 times 6 is going to give us, is it 48? Yes, I think 48, right? Because if I add 6 to it, I'm going to get 54. Yeah, so that's right. And then u is 2x cubed plus 1 to the power 8 plus c. So this is what we need to get at the end of the day. Good. Let's do the last one, then I'll give you a try question. So same idea here. Pick u to be the one with the highest degree. Look for du over dx, which is going to be 2x. And then this implies that du is equal to 2x dx, and dx will be equal to du over 2x. So this is going to give us, okay, so this is definite, right? So this one definitely we are not going to add constant to it. Good. So this is going to give us 2x. This one here is equal to u, so I'm going to have times u times dx is equal to this. So I'm going to have du divided by 2x, and the magic happens. 2x will cancel 2x. So we are going to have this one to be equal to integration from 0 to 1 u du, and this is to the power 1. So when I integrate, I get u squared divided by 2, then from 0 to 1. Now for me to plug in them inside, I need to substitute the u back to have something like x squared plus 5 to the power 2 divided by 2, 0 to 1. Before I can now plug in the value, I will show you the other way. So this is 1 squared plus 5 divided by 2 all squared minus 0 squared plus 5 divided by 2 all squared. So this is going to give us 6 squared divided by 2 minus 5 squared divided by 2. 6 squared is 36, and then this is 25. So when you do the subtraction, what you get? This should be 11 divided by 2. What is the other way? The other way is when I get here, for me to plug in this and this straight away, then I can find the interval for u. So u is equal to this. So it means that u squared divided by 5, when x is equal to 1, what will be u? U will be what? 6. So the interval here will be 6. When u is 0, when I put 0 here, when x is 0, u will be equal to 5. Then I have 5 here. So when I plug it in, I'm going to have 6 squared divided by 5 minus 5 squared. This one's supposed to be 2. 5 squared divided by 2. And this is basically the same thing as what we had here. So it's either you go through the u or you do backward substitution and then you do it anytime you are dealing with definite integrals. Oh, we have another one here. I think this one is the last one under definite integrals. So this, the same thing, let u to be equal to what is under the root. But remember, this can be written as 0 to 5, x divided by 144 plus x squared to the power 1 over 2 dx. So the one the highest degree is this, right? So u is equal to 144 plus x squared. So du over dx is equal to 2x. So du is equal to 2x dx, and dx is equal to du over 2x. So it means that this is going to give us 0 to 5 x u to the power 1 over 2, because u is equal to this, and then dx is du over 2x, and then x will cancel x. So this is 1 over 2, 1 over u to the power 1 over 2 du. And since this is not 1, we need to move it up and have it of the form u to the power minus 1 over 2 du. Integrate that, and we are going to have 1 over 2. This is u to the power half divided by half, because we are adding. So from 0 to 5. Simplify this, and this is 1 over 2 times 2. Now, what is u? U is equal to 144 plus x squared, and then from 0 to 5, because we need to do backward substitution since we are using the limit for x. And this will be 144 plus x squared from 0 to 5. So plug in 5 squared, minus plug in 4, plug in 0, 144 plus 0 squared. So this is 144 plus 25 minus 144. This cancel this, and the final result here is 25. So this is using U-substitution to solve integrals, and we've looked at definite and indefinite integrals using U-substitution. So try this and leave your final results in the comment section. So this is A, we have B here, we have C, we have up to E. So please, I hope you've seen the question. A, B, so you can take screenshot of that. Good. So solve this and leave your final results in the comment section. And guess what? In the next video, we are going to talk about another technique called integration by part. Integration by part was coming from the product rule from differentiation, right? So when you have two functions, that is multiplying, but here we cannot use the U substitution. For example, these two functions are product, right? But this one we can use the U substitution. But if we cannot use the U substitution, then we need to think about the product rule that we learned under differentiation, and this is what we call the integration by part. So see you in the next video.